Hello everyone, this is Nick FB. In the last video, we added support for rolling joints. And in this video, we're going to add the ability to apply multiple forces at different joints. So how I'm going to do that is first I'm going to add a force class, and we're going to implement drawable as well, so we can visualize those forces on our system. So right here I have a very basic class. There's no constructor or anything like that. All this is it implements this draw function required by this drawable interface. So in the constructor, I am going to ask for a certain joint to apply the force on, and also the force itself as a vec3. So here we are, I've created my constructor, we ask for the joint, and we ask for the force. So the next thing I'm going to do here is implement the draw function here by drawing a small line segment where the force is being applied. Okay, so this is the logic here to actually draw the line segment. We use the x and y position from the start and the end vector to start and end our line. I'm also drawing it in red and using a line with the size factor. So it might look a little goofy, we might need to rescale this force vector, but let's just draw it and see how it looks first. So in the index file, I'm going to have to create a new force here. And remember how it asks for a joint and a force. So I'm going to apply this on joint 0, which is going to be this one. And this is just for demonstration purposes. We're not actually applying any forces yet. This is just to see if it will render properly on the graphic. So now that I've created my force test, I can draw that in this loop function. Alright, and don't forget to run bun-dev to start the simulation. Okay, and so we have something set up here. This is the kind of thing that a little debugging can solve pretty easily. So the two things I changed here was I had a plus where it should have been a minus here, and I also doubled the length of this force vector just to make the line look a little bit longer than just the short one we had before. So far this is looking pretty good. I can test a different force to see if it'll rotate around this joint here. So for example, if I have a y component of -1000, it should be pointing upwards. And there we go. This looks like it's working right, and now I'm going to have to work on this structure class so that it takes in this force. And in fact, we want to take in an array of forces because we want to be able to apply multiple forces at different points in the system. So I'm going to go ahead and delete these testing lines first, and then I'm going to work on the struct class. Before I do that, we're actually at a good point to commit this force file just because we know it works. So over here in my struct, I'm going to change this external force from a vec3, and I'm going to change it to an array of force. I can also get rid of this applied to parameter in my constructor. I'm going to also need to make these parameters public so I can access them in the structure class. Now that I've applied these external forces in my draw class, I can also draw those forces. To me, this looks pretty good. I'm going to go back to my index file now, and we see an error, of course, because we have changed our constructor parameter types. In here, I'm going to go ahead and create an array of forces, and then I'm going to use that as my parameter. I'll use J1 as my joint, and I'll use 0, 100 as my magnitude. So I can replace both of these parameters with this variable f. Now, when I rerun that, I should now be able to visualize where the force is being applied. So far, looking really good. So why don't we try to add a secondary force? We can also change the magnitude, and let's rerun the simulation. And there we go. Now we're able to add multiple forces, and we can visualize them in the simulation. If we want to be able to visualize different magnitudes of different forces, we can change the length of this line segment here based on the magnitude of the vector applied. So what I did here is I've created this segment length variable using this translate function, which translates a number from one range to another range. It's basically a linear conversion. So what I'm doing is converting the magnitude of the force in the constructor from 0 to 1000 of these units to this 2 to 4 range here. And I'm going to put that in here. So now the end of the vector will be properly scaled based on the magnitude of the force. So I can go ahead and refresh that. We don't see that much of a difference yet, but let me try to make the visual even more distinct. So now a magnitude of 100 units will correspond to a segment length of 2, and a magnitude of 500 units would correspond to a segment length of 10 units. So that's it for this video. Once again, thanks for watching, and I'll see you in the next video.